Good morning. In this video, I will solve integral of x multiplied by tangent inverse x dx. So I have a product of a polynomial, which is x, multiplied by an inverse trigonometric function, which is tangent inverse. So we have a product of two functions of different type. Always when we have a product of two functions of different type, to integrate this product, we use integration by parts. So integration by parts is when we have an integral from a to b, in case if it's a definite integral, which is not our case because it's indefinite here, of u prime v dx, it's going to be equal to u by v between a and b minus integral from a to b u v prime dx. So one of our functions, we are going to choose it to be u prime, and the other, we are going to choose it to be v. The one that is going to be u prime, it should be easily integrable, or we should find its antiderivative very easily, because here we are going to use u, which is the antiderivative of u prime. And the other is going to be v, where we get v and v prime. So it should be differentiable. If we look here, if we choose u prime to be tangent inverse x, the antiderivative of tangent inverse x, in order to find it, we should use integration by parts. So it's not easy to find the antiderivative of tangent inverse x. I'm going to solve the integral of tangent inverse x in another video. You can check it later if you like. So tangent inverse x would be v, the one that is going to be differentiated. And u prime is going to be x. Always, when we have a polynomial times an inverse trigonometric, the inverse trigonometric is v. So, as I said, u prime is x, which means u is half x squared. V, it's tangent inverse x, so v prime, it's 1 over 1 plus x squared. Because, in case you don't know, the derivative of tangent inverse u, where u is a function of x, it's u prime over 1 plus u squared. And here, u is x, so x prime is 1. So we get that it's 1 over 1 plus x squared. So applying the rule of the integration by parts, I would become u by v, so half x squared tangent inverse x, minus integral u by v prime, so minus integral half x squared times 1 over 1 plus x squared. So we get half x squared tangent inverse x minus this half, I'm going to put it outside the integral, so minus half integral x squared over 1 plus x squared. Now, this integral, which is x squared over 1 plus x squared, it's a fraction of two polynomials. It's a fraction of two polynomials of the form integral of x squared over x squared plus a constant. To solve it, we have two options. Either we do a long division, so we divide x squared by x squared plus c, or we add c and we subtract c to the numerator, so we get x squared plus c minus c over x squared plus c, which becomes 1 minus c over x squared plus 1. Now, 1 here, it's x squared plus c over x squared plus c. This is why we have 1 here. And it's this second method that I am going to use. Now, if you want to see how we do a long division, you can check videos of improper fractions, integral of improper fractions that you have on the channel. So, continuing with the integration of the fraction of polynomials. So we add 1 and we subtract 1. So we get x squared plus 1 minus 1 over x squared plus 1, which is going to be 1 minus 1 over x squared plus 1. So we integrate now. Integral of 1 is x, and integral of 1 over x squared plus 1, it's tangent inverse x. And finally, we get that I would be half x squared tangent inverse x minus half factor of x minus tangent inverse x plus a constant c.